RT-11 was a small, single-user real-time operating system for the Digital Equipment Corporation PDP-11 family of 16-bit computers. RT-11 was first implemented in 1970 and was widely used for real-time systems, process control, and data acquisition across the full line of PDP-11 computers. Features multitasking RT-11 systems did not support preemptive multitasking, but most versions could run multiple simultaneous applications. All variants of the monitors provided a background job. The FB, XM and ZM monitors also provided a foreground job, as well as 6 system jobs if selected via the Sysgen system generation program. These tasks had fixed priorities, with the background job lowest and the foreground job highest. It was possible to switch between jobs from the system console user interface, and Sysgen could generate a monitor that provided a single background job. Source code RT-11 was written in assembly language. Heavy use of the conditional assembly and macro programming features of the Macro 11 assembler allowed a significant degree of configurability and allowed programmers to specify high-level instructions otherwise unprovided for in machine code. RT-11 distributions included the source code of the operating system and its device drivers with all the comments removed and a program named Sysgen, which would build the operating system and drivers according to a user-specified configuration. Developers' documentation included a kernel listing that included comments. Device drivers In early versions of RT-11, device drivers were built into the kernel at configuration time, but in later versions the device drivers were loadable. Because RT-11 was commonly used for device control and data acquisition, it was common for developers to write or enhance device drivers. DEC encouraged such driver development by making their hardware subsystems open, documenting the internals of the operating system, encouraging third-party hardware and software vendors, and by fostering the development of the Digital Equipment Computer Users Society. Human interface Users generally operated RT-11 via a printing terminal or a video terminal, originally via a strap-selectable current loop or RS-232 interface on one of the CPU cards. DEC also supported the VT-11 and VS-60 graphics display devices. A third-party favorite was the Tektronix 4010 family. The keyboard monitor interpreted commands issued by the user and would invoke various utilities with command string interpreter forms of the commands. RT-11 command language had many features that can be found later in DOS line of operating systems which heavily borrowed from RT-11. The CSI form expected input and output file names and options in a precise order and syntax. The command line switches were separated by /sign rather than dash used in Unix-like operating systems. All commands had full form and a short one to which it could be contracted. For example, rename command could be contracted to REN. Batch files and the batch processor could be used to issue a series of commands with some rudimentary control flow. Batch files had the extension BAT. In later releases of RT-11, it was possible to invoke a series of commands using a COM command file, but they would be executed in sequence with no flow control. Even later, it was possible to execute a series of commands with great control through use of the indirect command file processor, which took CMD control files as input. Files with the extension SAV were a sort of executables. They were known as save files, because the RT-11 save command could be used to save the contents of memory to a disk file which could be loaded and executed at a later time, allowing any session to be saved. The save command, along with GET, start, re-enter, examine and deposit are basic commands implemented in the KMON. Some commands and utilities were later borrowed in DOS line of operating systems. These commands include dir, copy, rename, assign, CLS, delete, type, help and others. Format command was used for physical disk formatting, although it was not capable of creating file system, for which purpose init command was used. Most commands supported use of wildcards in file names. Physical device names were specified in the form DDN, where DD was a 2-character alphabetic device name and the optional N was the unit number. When the unit number is omitted, unit 0 is assumed. For example, TT referred to the console terminal, LP referred to the parallel line printer, and DXO, DY1, DL4 referred to disk volumes. Logical device names consisted of 1 to 3 alphanumeric characters and were used in the place of a physical device name. This was accomplished using the assign command. For example, one might issue assigned LOABC, which would cause all future references to ABC to map to DLO. Reserved logical name DK referred to the current default device. If a device was not included in a file specification, DK was assumed. Reserved logical name SY referred to the system device. Later versions of RT-11 allowed specification of up to 64 units for certain devices, but the device name was still limited to 3 alphanumeric characters. This feature was enabled through a sysgen selection, and only applied to the DU and LD device handlers. In these two cases, the device name form became DNN, where D was D for the DU device and L for the LD device, and NN was 0077, octal. Software RT-11 was distributed with utilities which allowed a user to perform many actions. The utilities dir, dup, pip and format allowed a user to manage their disk volumes. TECO, edit, and the visual editors KED and K52 allowed a user to create and edit source and data files. Macro, link, and LIBR allowed a user to build their own executables. ODT, VDT and the SD device allowed a user to debug programs. DEC's version of runoff allowed a user to produce documents. Finally, VTCOM allowed a user to connect with and use another computer system over the phone using a modem. The system was complete enough to handle many modern personal computing tasks. Large amounts of free, user-contributed software for RT-11 were available from the Digital Equipment Computer Users Society, including an implementation of C. Although the tools to develop and debug assembly language programs were provided, other languages including C, Fortran, Pascal, and several versions of BASIC were available from DEC as layered products at extra cost. Versions of these and other programming languages were also available from other, third-party, sources. It is even possible to network RT-11 machines using DECnet, the Internet and protocols developed by other, third-party sources. Distributions and minimal system configuration the RT-11 operating system could be booted from, and perform useful work on, a machine consisting of two 8-inch 250 kilobytes floppy disks and 56 kilobytes of memory, and could support 8 terminals. Other boot options include the RK05 2.5 MB removable hard disk platter, or magnetic tape. Distributions were available pre-installed or on punch tape, magnetic tape, cartridge tape, or floppy disk. A minimal but complete system supporting a single real-time user could run on a single floppy disk and an 8K 16-bit words of RAM, including user programs. This was facilitated by support for swapping and overlaying. To realize operation on such small memory system, the keyboard command user interface would be swapped out during the execution of a user's program and then swapped into memory upon program termination. The system supported a real-time clock, printing terminal, VT11 vector graphic unit, 16-channel 100 kHz AD converter with 2-channel DA, 9600 baud serial port, 16-bit bidirectional boards, etc. File system RT-11 implemented a simple and fast file system employing 6-character file names with 3-character extensions encoded in radix 50, which packed those 9 characters into only 3 16-bit words. All files were contiguous, meaning that each file occupied consecutive blocks on the disk. This meant that an entire file could be read very quickly. A side effect of this file system structure was that, as files were created and deleted on a volume over time, the unused disk blocks would likely not remain contiguous, which could become the limiting factor in the creation of large files. The remedy was to periodically squeeze a disk to consolidate the unused portions. Each volume has only one directory which was pre-allocated at the beginning of the volume. The directory consists of an array of entries, one per file or unallocated space. Each directory entry is 8 16-bit words, though a sysgen option allowed extra application-specific storage. Compatibility with other DEC operating systems many RT-11 programs could be directly executed using the RT-11 RTS of the RSTSE time-sharing system or under a TEM on various releases of both RSX-11 and BMS. The implementation of DCL for RT-11 increased its compatibility with the other DEC operating systems. Although each operating system had commands and options which were unique to that operating system, there were a number of commands and command options which were common. Other PDP-11 operating systems, DEC also sold RSX-11, a multi-user, multitasking operating system with real-time features, and RSTSE, a multi-user time-sharing system, but RT-11 remained the operating system of choice for data acquisition systems where real-time response was required. The Unix operating system also became popular, but lacked the real-time features and extremely small size of RT-11. Hardware: RT-11 ran on all members of the DEC PDP-11 family, both QBus and UNIBus based, from the PDP-11/05, to the final PDP-11 implementations. In addition, it ran on the Professional series and the PDT-11 programmed data terminal systems, also from DEC. Since the PDP-11 architecture was implemented in replacement products by other companies, or as reverse-engineered clones in other countries, RT-11 runs on these machines as well. Compatible operating systems. Fuzzball, routing software for Internet protocols, was capable of running RT-11 programs. Shareplus Hammond Software distributed a number of RT-11 compatible operating systems including STAR-11, an early multi-computer system, and Shareplus, a multi-process multi-user implementation of RT-11 which borrowed some architectural concepts from the VAX VMS operating system. RT-11 device drivers were required for operation. Transparent device access to other PDP-11s and VAX VMS was supported with a network option. Limited RSX-11 application compatibility was also available. Shareplus had its strongest user base in Europe. TSX-11 S&H Computing developed and distributed TSX Plus, a multi-user, multi-processing implementation of RT-11. The only thing it didn't do was handle the boot process, so any TSX Plus machine was required to boot a T11 first before running TSX Plus as a user program. Once TSX Plus was running, it would take over complete control of the machine from RT-11. It provided true memory protection for users from other users, provided user accounts and maintained account separation on disk volumes, and implemented a superset of the RT-11 IMT programmed requests. RT-11 programs generally ran, unmodified, under TSX Plus and, in fact, most of the RT-11 utilities were used as is under TSX Plus. Device drivers generally required only slight modifications. Versions. Release history variants users could choose from 4 variants with differing levels of support for multitasking. RT-11SJ allowed only one task. This was the initial distribution. RT-11FB supported 2 tasks, a high-priority, non-interactive foreground job, and a low-priority, interactive background job. RT-11XM provided support for memory beyond 64 kilobytes, but required a mini-computer with memory management hardware. Distributed from approximately 1975 on. RT-11ZM provided support for systems with separate instruction and data space. Specialized versions Several specialized PDP-11 systems were sold based on RT-11. Lab 11 provided an LPS-11 analog peripheral for the collection of laboratory data. Peak 11 provided further customization for use with gas chromatographs. Data collection ran in RT-11's foreground process while the user's data analysis programs ran in the background. GT4X systems added a VT11 vector graphics peripheral. Several very popular demo programs were provided with these systems, including Lunar Lander and a version of Space War. Gamma 11 was a packaged RT-11 and PDP-11/34 system that was one of the first fully integrated nuclear medicine systems. It included fast analog-digital converters, 16-bit color graphical displays, and an extensive software library for development of applications for the purpose of data collection, analysis and display from a nuclear medicine gamma camera. Clones in the USSR. Several clones of RT-11 were made in the USSR, RAFOS a Euro-SM EVM, FOBOS a Euro-Electronica 60, FODOS, Rudos, OS-DVK a Euro-DVK, OS-BK11 a Euro-Electronica BK, Master 11 a Euro-DVK. Notes. External links, PDP-11 How to Guide with RT-11 Commands Reference, RT-11 Emulator for Windows Console.